Hi, in this tutorial we are going to solve a question related to reactions of aldehydes and ketones. The question asks us predict the products of the following reactions. If we look at the reactants, we have a common reagent which is a ketone, and this ketone is reacting with various reactants. Okay, let's start from the first reaction. The first reaction, ketone with sodium borohydrate. As you remember, sodium borohydrate is a reducing agent. It's a hydride source. What happens when an aldehyde or ketone, or in general a carbonyl compound, reacts with sodium borohydrate? We are going to introduce a carbon-hydrogen bond. Let's write the product here. So first, I'm going to draw the reaction here as if like a mechanism, but it's not a detailed mechanism. Just let's write here the ketone first, then let's write just the hydride. As you remember, this is a nucleophilic addition reaction. Hydride is going to attack the carbonyl carbon, and we are going to form a tetrahedral intermediate. Then we are adding acid. So basically the resulting tetrahedral alkoxide will be protonated by addition of acid. Then we are going to form an alcohol. So basically, when you use a ketone, when you reduce with sodium borohydrate, we get generally, not generally, it's always a secondary alcohol. Let's move to the second question, or second part of the question. Here we have methyl magnesium bromide. It's a Grignard reagent. So when we have Grignard reagent and aldehydes and ketones, again the same reaction, nucleophilic addition to the carbonyl, but here we are going to introduce, instead of carbon-hydrogen bond, we are going to introduce a carbon-carbon bond. Here again I'm going to draw a like a primitive reaction mechanism. When you have methyl magnesium bromide, Grignard reagent, it's a source of carboanion. So basically methyl anion, and let's finish drawing this one. Again the same reaction mechanism. It's a nucleophilic addition reaction. Then by addition of acid, the alkoxide intermediate will be protonated, and we are going to form again an alcohol. In this case we are going to form a tertiary alcohol because we are forming a carbon-carbon bond, single sigma bond. That's the reason why we get a tertiary alcohol. Let's move to the third part of the question. Here we have alcohol, acid catalysis, and here we have carbonyl compound, aldehyde or ketone. In general, we form acetals. Generally, two equivalent of alcohol adds to carbonyl carbon, and we form acetals. So let's draw the acetal here. So we are going to add 2-methoxy to the carbonyl carbon, and carbonyl oxygen is disappearing. So let's move to the next part. Next part is a primary amine. When we react primary amine with aldehydes and ketones, we form imines. Basically, instead of carbon-oxygen double bond, we are going to form carbon-nitrogen double bond, plus a water molecule will be released. So let's write here. So this is going to be an H. Sorry, it's going to be methyl group there. Plus here, let's write here water. So basically, the particular thing about imine formation, when you have a ketone, it reacts with a primary amine, and we form carbon-nitrogen double bond here, plus one water molecule. Let's look at the next one. The next one is similar to the previous one, but instead of a primary amine, we have here a secondary amine. What's the unique thing about secondary amines? Instead of imines, we will form another molecule which is called here, let's say CH3. These are called inimines. Basically, alkene in amines. So basically, we are forming an alkene and amine at the carbonyl carbon in amine formation. Let's move to the next question. Next question is with a ketone and hydrazine, and in the presence of potassium hydroxide, a strong base. Basically, you have to know this specific particular reaction. This is called Wolff-Kishner reaction. So basically, when you react a ketone with hydrazine, we are going to convert ketone or aldehyde into alkanes. So we are going to introduce two carbon hydrogen bonds here. So let's write the product here. So like we have here two new carbon hydrogen bonds. So this reaction is called Wolff-Kishner reaction. Okay, let's move to the last part of the question. Here we have triphenyl, and here we have triphenyl group, here a phosphorus and carbon phosphorus double bond. So these reagents are called ylids. When you have ylids reacting with aldehydes or ketones, we synthesize alkenes. So basically, this carbon will be introduced here. We are going to form a carbon-carbon double bond. So whatever here you have, you are going to introduce as substituent. For example, here we have two hydrogens. The carbon-carbon double bond or alkene functionality will have two hydrogen. So let's write here. So instead of now carbon-oxygen double bond, we are going to form this molecule. So basically, you are going to introduce this part over here, and we are going to form an alkene. So basically, in this video, we covered 7 reactions. These are the general reactions of carbonyl compounds, especially aldehydes and ketones, with various reagents, reduction here, acetal formation here. We cover imine formation, in amine formation here. With hydrazine, we introduce alkane functionality, and with ylids, these are called Wittig reactions. Wittig reactions produces alkenes. Thank you so much for watching this video.